Okay, this Sunday night, we're going to talk first about complex numbers, right in the form of a plus bi. This is your real number, and this is your imaginary number. It's some b times an imaginary number, okay? Remember, given that I, this imaginary number I, equals the square root of -1, and I squared equals -1, we're going to go ahead and simplify these numbers. Now notice what I have here. I've got 4 minus 3i times 3 plus I. All right, and I'm going to convert that and simplify it, okay? So I'm going to do just FOIL, right? First times first is 4 times 3 is 12. And then my outer, remember our FOIL. The outer is 4 times a positive I, that's 4i. My inner is -3 times +3, but it's -3i. -3i times 3 is -9i. And then my last is -3i times +3i, which is a -3i squared. I've got an I times I in there. All right, so let's simplify. Notice 4i and minus 9i is -5i. I've got this 12, so I've got this right here simplifies to this. And then I've got -3 times what's I squared is -1. All right? 12 minus 5i, and this ends up being negative times negative is positive, and it's 3 times 1, so that's plus 3, okay? So obviously I rearrange it, so 12 plus 3 minus 5i simplifies to 15 minus 5i, and that's a, my real number, plus bi, which b is a -5, okay? And here's your imaginary number, the real number and the imaginary number of a complex number, okay? So we just simplified something with I in it, okay? So you'll have to do that tomorrow. Here's my graph. Here's the imaginary axis, the real axis. There's 15 minus 5. There's our number, okay? All right, now let's go ahead. We're going to talk about going from polar to rectangular, okay? Two techniques that might help are, one, sometimes you can multiply both sides by r, and you might get something like an r squared, which you can say is x squared plus y squared, which helps us out if we're going from polar to rectangular. So you can multiply maybe an r by an r and get r squared, and then substitute this. Another similar technique is kind of when you square both sides of the equation, okay? So here's an example. So these are two techniques that help us from going from polar to rectangular. Okay, so here's an example. I have r equals 4 sine theta. Well, this is not anything right now, but I'm going to multiply both sides by r. Okay, notice I've got r times r, and then I multiply this by r and this by r. So now I've got r squared equals 4r sine theta, okay? And I just kind of rearrange put the 4 first. So what's r sine theta? That's y, right? So that's what helps us out here. So I've got 4y. And what's r squared? That's x squared plus y squared, okay? All right, remember that was one of the things that was given, okay? And just to make sure you remember this, we had this, remember, x equals r cosine theta, y equals r sine theta. Remember, r squared equals x squared plus y squared. Remember, tangent is opposite over adjacent, or y over x, tangent of theta. So remember those. We've kind of gone over those a lot. This just comes from the triangle that we build on the unit circle. Okay? So that's why this helps out here with this r squared, because we substitute in x squared plus y squared. Okay? So hopefully that makes sense for everybody. Okay? All right, now I have to complete the square. I'm going to move this 4y over to this side and get the 4y with the y squared. Okay, so I subtract 4y from both sides, and now I've got x squared plus y squared minus 4y equals 0. And when I complete the square, I don't have to mess with this x squared. We're fine there. It's the y squared minus 4y. I need a constant. So remember, we divide this right here, okay? Notice I divide this coefficient by 2 and I square it and add it here. That's the last term. And I'm kind of leaving this form as a technique because that's going to be -2. Guess what? That's what I put here in parentheses. This is what this y minus 2 squared creates. Y squared minus 4y. And this would be -2 squared would be a plus 4. Okay? And I added this here. So guess what I have to do? I have to add it on this side as well. So remember, if I want to create from this right here, If I want to create a perfect square, I divide this by 2 and add it here and add it here. Both sides of the equal sign. So I added this negative 2 squared and a negative 2 squared. This trinomial comes from this right here, y minus 2 squared. Okay, so I've got x squared plus y minus 2 squared equals 4. Remember and that's a circle. Remember the equation of a circle is x minus h squared plus y minus k squared equals radius squared. And remember, h comma k is the center of your circle. Okay, all right? And my radius would be 2 here. Okay, 4 equals 4, so 2 squared. And you're not going to have a radius of negative 2. It's just going to be a distance here. So anyway, there's your circle. We just converted this. Here's our equation: x squared plus y minus 2 squared equals 4. All right. Rectangular to polar. I've got x squared plus y squared equals x. This right here is r squared, and what's x is r cosine theta. All right, and we're going to solve for r. Okay, notice what I do here. I want to get r by itself. Both sides have an r, so I divide both sides by r. So this cancels out. This r and the squared cancel out, and I get r equals cosine theta, which we know is a circle. Here's one, on our, polar coordinates. Okay, so it's a circle, okay? All right, so that's to get us started for us, enough to get us working tomorrow. Hopefully you're not going to watch this video. Have a good night, guys. It's only 6 minutes and 40 seconds.